Okay, we are going to be looking at section 3 today. So let me get that down there. So functional groups. You guys got a page on functional groups, so I'm just going to, I don't want to click out of that yet. But you guys had a page with your functional groups on it. So that'll be something very important to have from this section on. All right, so let's look here. The first slide. Elements and organic compounds. So far we've seen carbons and hydrogens, and we've seen where we can get any of those halogens, which is in column 17 on the periodic table, fluorine, chlorine, bromine, iodine, and we just call them chloro, bromo, all that. That's what we've seen so far. So let's look at a little bit more of this. So let's see here. Carbon atoms form bonds mostly with hydrogen and carbon. So fill your notes out. You're going to be getting points for doing this. Also, they can form with oxygen, nitrogen, sulfur, and then of course our halogens, we've already seen them do that. So here's the really important thing that I want you guys to see here. We have seen where hydrogen needs a single bond and carbon needs 4. I've also told you that our halogens need a single bond. So we know that we can get something like this, and our hydrogens are happy and our carbon is happy. But I could also put a single chlorine here, and chlorine's happy. Chlorine only wants one more valence electron. Now, nitrogen, for instance, it needs 3 bonds. So covalent bonds, it wants 3. All right. So if I have a nitrogen here, I may have carbons like that. So it could look like that, but it needs 3 bonds, and then it has its own 2 electrons right there. All right. Oxygen, same way. I can do this and then have hydrogens. The thing is that oxygen will want 2 covalent bonds. So it's not happy right now. Now it might go like this and have a hydrogen. It could have a double bond to that oxygen and then it's happy. It could do all kinds of stuff. It can do another carbon like that. All right, so there's all kinds of stuff. As long as it has 2 bonds, that's what makes it happy. All right, let me get rid of some of this. All right, so as I scroll on up here, functional groups are a characteristic feature of organic molecules, which means that they have carbon, right? Organic molecule means carbon. So there are a bunch of carbon hydrogen chains that have these other things coming off of them. And they behave in a predictable way if we know them. They're composed of an atom or a group of atoms. So like some of them are going to be much more flammable, or it's going to depend on if it's a solid, liquid, or gas sometimes, or if it at room temperature, what it's going to be at room temperature. All right, so groups that replace a hydrogen in the corresponding alkane, so that's a functional group. It's going to take one of those 4 hydrogens off, or one of those 3 hydrogens off, and you're going to replace it with this group. And it's a way to classify these families of organic compounds. All right, so the first ones that we will see in the upcoming sections are alkenes and alkynes. So we're starting off very simple. Instead of just a single bond carbon, now I'm going to double bond that carbon. Remember, that means it's sharing 2 sets of electrons. Or I can triple bond that carbon. Now these are hydrogens. Remember, we tend to draw it like this. But that, in real life, they're kind of angled, and remember, we twirl them around. So alkenes have double bonds, and alkynes have a triple bond. And when we name those things, it's just, I'm jumping a little ahead though, we'll get into that. Alkane was A and E. Well, guess what? Alkenes are E and E, and alkynes are Y and E for the naming. All right, so anyways, let's look at these groups. One of the big ones are alcohols, and alcohols have what are called a hydroxyl functional group. Now this is going to help you with the worksheet today. There's a hydroxyl there, which means that I have carbon and carbon, and then an oxygen and a hydrogen. There is that OH as soon as I see an OH. And an OH by itself. An OH by itself is going to be an alcohol. That doesn't mean that I have, an oxygen with something else attached to it. That doesn't mean that I have COO or anything like that. It is just CO with an H. That's it. All right. these quickly, and then we'll break them down in each section. We'll look at them individually. So we're just going to go quickly here. An ether is an oxygen atom that is between two carbons. So it's right in the middle. So we have carbon, oxygen, carbon, and now, who knows how long these carbon chains are? It could be like that. All right, so it's just a random oxygen stuck there in the middle of carbons. All right, let's scroll on. Now these two are very, very similar, and we'll get a section where these two are done together. Aldehydes and ketones. Aldehydes contain a carbonyl group, C with an O, and that is right here. You have C with an oxygen. Now, of course, your carbon needs 1, 2, 3, so we have to have that fourth is a hydrogen, but it is a carbon with a double bonded oxygen. Now look, ketone also has a carbonyl group. So here is a carbon with a double bonded oxygen. So it looks very similar to this. The difference is this is on the end of the molecule, and this one is in the middle. So if this CO is on the end, then it is an aldehyde. If it is in the middle, it is a ketone. All right. We have carboxylic acid. Now this is why I was talking a second ago about that double bonded oxygen. So look, I have another double bonded oxygen, but look, I have also an OH. So I have an OH with another oxygen. So for this to be an alcohol, it would just be OH. That's it. I would not have this other oxygen off to the side. Right away, that is not an alcohol. Okay, it has parts of an alcohol in it, but it is not an alcohol. All right, so if you have COOH, that is a carboxylic acid. You will often see this written as this, like that. When you see this, it means this right here. Okay, that is the same thing. That is a carboxylic acid. Now look, there's something else very similar right here. This is an ester. I have a carbon, COO, just like this COO. Now this one had an H, and it ends. That ends it. This one, though, has COO and another carbon, so I could just keep adding carbons. That is called an ester. Once again, I know we're going through this quickly, but we will have a whole section devoted to just these guys and how to name them and what we do with them. Okay, so I'm not going to get too much into that. Amines and amides are also very similar in that they both deal with nitrogen. So I will, once again, it all deals with being on the end. So you have a nitrogen right here. I'm sorry, an amine is the functional group is a nitrogen atom. Sorry, I didn't mean on the end. So if you just have a nitrogen, like you have carbons and hydrogens and a nitrogen, then you're going to be an amine. Now an amide, though, you look here, you have a nitrogen, but you have a double bonded oxygen there. So this double bonded oxygen, this carbonyl group, is really popular. It's in a lot of these. It's just what else is with it? Is it by itself? And that's it? Does it have an OH? Does it have another C? Does it now have a nitrogen? Like it's a very popular group in this, but this one will have a nitrogen and then also the oxygen. All right, so here's the table of functional groups. You guys have this, and this is really, it makes it a lot easier for you guys because when we get to the end of this chapter, we have done all of these. And then I'm going to give you a random carbon-hydrogen chain, and I'm going to expect you guys to know which one it is, how do we name it. If I give you a name, you can draw it out for me. And I know it may look overwhelming right now, but usually this test is one of the best tests in chemistry too. Like kids really get this. So anyways, you can look here where, like a carboxylic acid, C, double bonded O, O, H. Here's a C, a double bonded O with an O. That's an ester. Here's another C, double bonded O, with just in between two carbons. See, when they leave these like this, that's a carbon and a carbon, so it's a ketone. Double bonded O, it's on the end, because there's an H. That ends it, that's an aldehyde. Okay, so just all these different functional groups. They get tricky though, because they all have these double bonded oxygens in it. All right, so let's look at this. We have, number one, we need to classify the following as either an alcohol, ether, aldehyde, ketone, carboxylic acid, ester, or amine. All right, so right away, I'm like, ooh, I have amine, which amine and amides are nitrogen. Amide's not an option, so if I have something with a nitrogen up here, right away, I know that's an amine. And I do. Look at number 3. This is an amine. Now, if I had a oxygen coming out that carbon, it turns into an amide, right? Okay, so let's look at this. Now I have number 1, once I get that out of the way, I've got number 1, C, 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 and then there's an OH, and that is it. A single OH, nothing else attached to it, that is going to be your alcohol. Alright, so now let's look at this. You have just a random, on number 2, you have a random oxygen right in the middle. So look up here at this thing. Sorry, I'm not going to erase all that yet. You have just a random oxygen in the middle. Look at this right here. On each side is carbons. That is your ether. Let me do this. So this is my ether, the second one. Alright, now number 4, you have a double bonded oxygen, sorry for the mess here, and then an OH. So it's not an alcohol because it also has that. So I'm looking for COOH. So let's look up here. Look at this, COOH. It's a carboxylic acid. Oh my gosh, trying to get this here. Oh, there we go. So a carboxylic acid. This one is a little bit of a mess. This double bond should go right here. So look at this. I have, oh, I'm sorry, not right there. Everything shifted over. It should look like this. Let's get rid of that too. That is what it should look like. All right, so I have COO instead of an H. I go COO and then another C. So let's look back here at our chart. So it's not COOH. COO, and then there would be another C. Alright, so that was, sorry, that would be your ester. Okay, so this is ester. Okay, so as we get through each individual section and we're dealing with each of these, it becomes easier and easier for you guys to point them out and know which one it is. Alright, so let's delete, clear the ink. There's the solutions. And that takes us into 17.4, where we start looking at these individually. Or sometimes they come as a pair in each section. Anyways, if you have any questions, need any help, let me know. You guys have a great rest of your day.